Now, I understand that just as there are for corporate PPAs and for real estate leases and for commercial leases, they're all different pricing structures that you can imagine. And I used to get so worried. I said, oh no, I have to model it this way or that way. What you need to know is the general modeling and economics of different possible leases and just make sure you value them together. And then uh, uh, you can understand how the different pricing structures affect the risks. And I've been told that there are all sorts of different things. You can include the O&M, not include the O&M. I didn't even put O&M in this analysis. You could have a flat lease without inflation. You could have a lease per kilowatt hour. And it's a fascinating, really thing to think about. I think if you don't have a lease that has a flat rate per kilowatt hour, it's kind of like a PPA agreement. In the old multi-tariff or multi-part rather PPA agreements, you can hardly remember them, they would have a capacity payment and an energy payment and a fixed O&M payment that's variable and a fixed O&M payment that's fixed. And you would try to mold all of these things to protect the project from risk and then be able to bid a lower price because the bank would like that. Now it's going to be harder to do that, I think. How would you somehow put a provision in, number one, that if this thing degrades more, uh, uh, then you protect yourself against the degradation. How would you protect yourself if you use the battery a lot more and you lose it badly? How could you protect it against that? How could you protect yourself if you have more cycles than the lifetime of the battery goes down? There are fascinating issues with all of that. Okay, so we could um, put inflation indexing, and this is kind of repetitive. Now, I've tried to just write this down. The first lease is the one we already did, and I'm just going to go all the way back now to where I was. I still have the file open, and then so now we can move once we have this total amount of the lease here, which is wrong. This is yes, it's right here. It was this PMT function. Once we have this total amount of the lease, one thing we could do was just charge that as a flat amount. I call that like a capacity payment. That's like an old-fashioned lease payment that you'd have. And again, if a bus had this, they could be crazy and make the battery degrade more because they're not maintaining it well, or they could use the bus much more than you thought, and then the remaining life would go down. So that's the risk about that. Now, the other thing we could do, so the next thing we could do is we could uh, uh, put make, excuse me, I've got to get back to the PowerPoint slides here. I don't know how this is working. We could make a lease that goes up with inflation. Now, what that means is we have to figure out how much to reduce the lease rate today and allow that lease rate to go up with inflation in the future. The real way we have to do this is take out the expected inflation that we have and get it down. So our IRR, for example, implicitly has an expected inflation rate in it. And if the inflation is much, much higher, the actual inflation, then you get a higher lease rate and you're protected in terms of the real return, not the nominal, the real return. You're protected against the inflation. Now, here's mechanically how we can do that. And I might have made a mistake here. So what you do is no, I don't think I did actually. So you take here's our nominal lease, and then it's a little bit tricky, This one's, and I wanted to come up with a PMT formula that works when the inflation rate changes. If the inflation rate was constant, if the inflation rate was constant, I made a whole bunch of very technical kind of levelized cost formulas, and you can take the the nominal rate, 1 plus the nominal rate divided by 1 plus the inflation rate, get a smaller real rate, and use the PMT function. If the inflation rate, and I happen to have it on the right thing, if the inflation rate changes over time, we can't use that PMT formula. But instead, it's not that hard. Again, you have to experiment with it. Now, academics that drive me nuts these days with all their wonderful integration formulas and everything else, what they do, yeah, they don't. If you work through these with a simple example and prove that it all works, uh, uh, that's how you can come up with the formulas. I don't know if I should have digressed into this integration formulas, but we just take the net present value of our index, and we do that over the tenor of we do that over the lease term. Okay, so we're essentially taking our expected inflation out. And now if you take the PV, I didn't put that in my Excel, it's a big deal. This is a big deal. I just accidentally ran into this, but if you use 0, it's going to screw up because it's going to take the NPV to year 0. We want to take the NPV and not be trapped to the XNPV. We want to take the NPV and go over to the first month. I don't want to start from here. At least I think I don't. Maybe it wouldn't be that bad if you did, but I want to start from here, and then I want to take the NPV and I go over here. And the way I try to explain this and think about it is, instead of multiplying the flags, you put a little if statement in the flag, and when you put a little if statement in the flag, then you get the true and the false, and that prevents the NPV formula from accounting for those things as 0. And then you can compare that to the PV of 1. That's like an annuity. It's almost like making this thing into a payment function, NPV or the NPV divided by the NPV of 1. And that goes over again, everything's over the initial lease term. And when you do that, that gives you, and I've just worked through it, it gives you, once you do that, you take the nominal capacity, you take the nominal capacity payment and divide that by that little factor, and you can get the lease, the amount that you have to pay for the lease that's going to inflate over time. And if you don't believe me that it really works, well, down here we have we can look at here, we can look at the NPV this is the NPV of our lease at the target IRR, monthly target IRR. Remember, this was the 10%. Somewhere up here, it was whatever. Okay, it's the 10% adjusted for monthly. And remember, what we did is we said, well, this is the remaining amount we have to collect other than a residual value. This is the capex minus the residual value, and we did a PMT on a monthly basis to get that. And this amount that you have to collect, that's the NPV. That's the NPV you want. And if you use those true and false, and if you take the NPV at that rate, it proves it works. And then if we take this amount, but then when we take this amount, you notice what I'm doing is I'm multiplying it by our inflation index. I know this must be torture if you're trying to watch it, but again, I'm doing this just because in the class I had, I went through some very general ideas about this, and I wanted to make sure and go through some much more specific ways to do it. And then so we inflate this, and if you would just kind of do a little thing like this, I suppose. Oh no, we have to go all the way back here. That copying wasn't that generic macro needs a little bit of work, I guess. Here's the real rate versus the nominal rate. That's just F11, and you press Alt EL. Okay, and then now the next thing we could do is almost the same sort of thing. We could take the degradation, uh, uh, and now we can't adjust the lease for obsolescence. That's a risk we're going to have to take no matter what. But we can, if we have a quantity lease, we can recognize that when we're going to take this total amount we need to collect, we're going to divide that by some quantity we have, so we can make it a per unit or per kilowatt hour lease. That's the same with a corporate PPA, solar versus a non-solar PPA, a capacity payment. You know, it's always there, this business of when you should multiply, you should have a quantity versus a fixed amount. For batteries, it's very tricky. For solar, it's kind of obvious. You need the investor to take some quantity risk. For batteries, it's the user who's going to choose how they use the batteries. It's almost like a combined cycle kind of natural gas plant when the user decides how much to dispatch it. The user decides how much the battery should be dispatched, so you can make an argument that we need to just collect our full money, but then oh, it's really interesting. But then if you use it more, the life changes. So it's kind of like a variable cost. It's a very tricky thing to get this lease exactly right. Now, if you do this, you're going to have to collect more based on the initial generation, because we're going to take our initial generation and then we're going to multiply that initial generation. Now, it would be really nice. And this is my little F2 rule. All this other crap about best practices, blah, 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 go to heck. That what I say is you should press the F2 and see where things are coming and be able to explain things. I'm not sure I'm being able to explain things and then understand it after you've put them all away for a while. So our actual generation goes down based on our expected generation. Now, of course, the actual degradation could be very different than the expected generation. And we can then we can say, okay, well, this would be our lease per kilowatt hour if we had no degradation. We're going to have to charge a higher amount if we have higher degradation, and this comes from exactly the same sort of NPV divided by PV. Sorry, again, it's technical, it's boring. I know it's boring as heck, but uh, um, uh, uh, you know, if you're actually going to work on these things, you can go crazy trying to figure out these formulas, or you could do the much worse thing, be proud of yourself. Please, oh, you can be proud of yourself by making some macro with a goal seek. How horrible would that be? Okay, what you want to do is think, really think through the problems, and then we can combine them both. And then we can say, okay, well, this is the amount we'd have to charge if we don't inflate the price. But if we inflate the price, here's the amount we have to charge. And then finally, you can get the different lease that's applied. And I'm going to skip through this and go to and this is a little bit of a mess, but we put what kind of lease we have. So I put 4 different kinds of leases, and the very first thing I want to do is make sure that if the expected values equal the actual values, that we have exactly the same sort of return. And I'm looking at this project IRR. I hope you were looking at that along with me to test things out. And the reason when I'm doing that, I'm going to save this now. I have a case, and this is always going to be the first case. I'm going to make sure that all our expected numbers are exactly the same as our actual numbers, okay? That's kind of like our first case. And when you put these scenarios together, when you have some problems like this, I beg you, take taxes out, for example. Make sure that you can have a case where you can prove to your boss, to investors, to lenders, that this structure is really working. This is not, they're going to look at these formulas and have no clue as to what you did, but then you can you can really prove how they work. Okay, and I think that's really part two. So we've gone through how to kind of come up with the total amount of money you need to collect for your first lease payment, and then we structure it. Now, the third part is going to work through a little bit how we evaluate the risks. So now let's move to risk analysis. And when we move to risk analysis, the big deal is for all of these possibilities, we have a expected or predicted degradation in structuring our lease, but then we could have an actual degradation that's very different. And if we have that, we've built our lease up with a forecast, but our forecast has been wrong. And when our forecast has been wrong, if our battery is fully degraded by the end of the lease term because we have much higher degradation, we have a worthless, we have something worthless, then we've taken that risk. That's the residual risk. That's how we're going to start to measure the residual risk. And then, of course, I've said that we're going to put it all into a portfolio. So that's enough of the price structuring of a lease.